Do you want to hear the greatest sound mankind has ever produced? You think it's Mozart? No, mate. Oh. Got myself a beverage, and we're gonna finish off this paper, this Pure 3 paper, new spec. This will be the last Pure 3 video I do on YouTube, because I've uploaded all of the exam hack series on Patreon, and we'll be uploading more stuff like past paper run-throughs, hardest exam questions, and a bunch more other stuff. So if you want that, we've had hundreds and hundreds of people get it, and they've all given me heaps of positive feedback. So if you want it, go grab it, because I won't be uploading any more P3. I'm doing this to help and also to promote it. I'm telling you, like, if you want it, it's all on Patreon. And I put so much effort into that stuff, man. And it's finished, and it took me a while. Okay, so we went through these yellow ones. I marked off some yellow ones in part 1. And so I guess I'll just run through these ones that I haven't highlighted. We'll finish off the paper. And yeah. So yeah, how's everyone doing? I'm going to try and keep it chill, try and enjoy this. And like I said, these past paper run-throughs, I don't want them to be as serious as the exam hack series when we're really getting into it. So yeah. Let's do it, but we'll do some questions. Okay, let's see. Don't know if I need a little bit of zoom action here. What do you think? I think it's alright. Let's try this. Okay. Sketch the graph. So, I've already done the yellow ones, so if you want that, they're in the part 1. I'll put a link in the description. Okay, so sketch the graph of this. Well, this is an absolute value. So the graph, it's one big fat mark. The graph will look like, well, let's have a look at what this graph looks like. I feel like I want to zoom in a little bit. How do I do that? Well, that's too much. I don't know if I zoomed in there. Okay, anyway. So this graph, what does this look like? Well, let's just have a little sketch here. Well, if we want to sketch something like this, well, it's got a gradient of 2, and when x equals 0, y equals to, well, when 0, y will equal to -3. So it's here. And then it's gradient of 2, but then let's also look at when y equals 0. When y equals 0, we get 2x equals 3. So I'm just getting a rough idea of what this graph looks like. Equals to 3/2. So this is at 3/2. So it'll be roughly here. And it does say sketch. So, you know, the graph of y equals 2x minus 3 is going to look like this. Yeah, I really feel like I need to zoom in here. Let me just sketch this bad boy and I'll figure that out. Okay. So that's what that graph looks like. But because it's absolute value, meaning the y values can never be negative, so actually when it hits this x-axis, instead of following through, it's just going to be sort of reflected or like bounce off. So it's actually going to look like this. So if you sketch it properly, you could put a key point. -3, you could put 2/3. Oh, what is it? 3/2. 3/2 here. It's the x. It's not the y. It's the y. And so, you know, it's going to look something like this. Just a rough sketch. You could even put in that this is, you know, y equals 2x minus 3. This part. Okay, so it looks like that. Okay, and let's continue. So solve the inequality. And I've done this a bunch of times, and I've got a method for all of the different ways that they do it in my inequalities video on Patreon, in the exam hack video. But for this one, so what we want to do here is we want to square both sides, because that will allow us to get rid of the absolute value sign. So if we square both sides here, and I'm not going to go into too much detail of why it does that, but basically like this equals this. When we square it, we can just get rid of that absolute value sign. Okay, but this is only valid, we can only square both sides and keep this this inequality sign in the same direction if both sides are positive. Clearly this is always going to be positive, this 2x minus 3 is always going to be positive, but this 3x minus 1, well, this is only going to be positive or greater than 0 when, if we rearrange all of this, is 1/3. Okay, so we're only interested in solutions for which x is greater than 1/3. That's important when we're dealing with these ones. So now we can continue. This will equal to 3x minus 1 squared, and that's greater than 2x minus 3 squared. And now we can just solve this thing. So this will be 9x squared minus 6x. Minus 1 will be plus 1 is greater than, well, this is 4x squared. Then we'll get what? 2x times 3 minus 3 is minus 6, it would be minus 12x, and plus 9. So take all this stuff over, we'll get a 5x squared here, minus 12, this will be plus 6x, and this will be what? Minus 8 is greater than 0. And so now let's solve this. So we want to find the roots of this so we can see where this is greater than 0. So we actually want to solve this thing here when it's equal to 0. So how will we solve that? We'll use that quadratic formula. So it'd be minus b plus or minus the square root of b squared, which is 36, minus 4a, which is 5c, all over 2 times 5. So that's just from the quadratic formula. You get your calculator out. And you get 196 square root, so 14. So you get x equals to minus 6 plus or minus 14 over 10. So we're going to get two solutions here. So we'll get x equals to minus 6 minus 14, so this is going to be minus 2, and x equals to minus 6 plus 14 divided by 2. Minus 6 plus 14 divided by 10, which is 4 over 5. So now if we want to know where this thing is greater than 0, well, let's just have a look. You know, the graph will look something like this. You know, this is like minus 2, these are roots, and this is 4 over 5. So where is this? Where is this greater than 0? Well, it's greater than 0 here and here. So that means this thing, 5x squared plus 6x minus 8, that curve is greater than 0 when x is less than negative 2 and when x is greater than 4 over 5. Okay, but are both of those solutions valid? No, because we're only interested in solutions that are x is greater than 1/3. Why is that? Because that's the only we can only have solutions greater than x is greater than 1/3 because that's because of the squaring. We're only allowed to keep this inequality the same when we square these two things if both sides are positive. Why that is, I don't really want to go into that, but so this is the only solution we care about. And that's the answer. Boom shakalaka. I really want to zoom in. I need to zoom in here. I feel like that'll be nicer. Yeah, there we go. Okay. Oh, and we need to check the answers because I'm doing this for the first time, so I don't know. I got the answers up here. Also got the formula sheet, which we might need. So what was this question? Where are we at? This was question 3. Okay, question 3. Yeah, so only x is greater than 4 over 5, which is what we got. Boom, baby. Okay. The parametric equation of a curve is, okay, so we have x equals to e to the 2t minus 3. This seems a little thick. Let's try that. that looks better, equals to e to the 2t minus 3, and we have y equals 4 ln of t. Okay, so where t is greater than 0 and says when t equals a, the gradient of the curve is 2. That means that when the gradient of the curve equals 2 when when t equals to a. This equals 2. So if we find what the gradient of the curve is, and we set it equal to 2 when t equals a, then we can show this. So we want to show this. So how do we start off things like that? We have to look at what they give us and look at what they want. And what they want is they want some equation relating a's. And they've only given us one piece of information, and that is that the gradient of the curve at t equals a is equal to 2. Okay, so what is the gradient of the curve? Well, we need dy by dx. And what is that equal to? Well, this is a curve defined by parametric equations, meaning we're defining a curve with one variable rather than two. So this we can say is equal to, dy by dt times dt by dx, right? Because they'll cancel and you get dy by dx. So therefore we can say dy. What is dy by dt? Well, dy by dt is here, and this will just be equal to 4 times this differentiated in terms of t, ln of t, which is on your formula sheet if you need it. So where is that at? So here's your differentiations. So you can see that ln of x goes to 1 over x. So this goes to 1 over t. So this equals to 4 over t. And also we want dx by dt. And what does that equal to? Dx by dt equals to, well, this thing differentiated is going to equal to this top part times down by this top part differentiated, which is 2 in terms of t, and then you keep all this the same. Okay, so now we have dx by dt and dy by dt. Now we can find dy by dx. So therefore, dy by dx equals to dy by dt, which is 4 over t, we found there, and times dt by dx. So dt by dx will just be 1 over this, right? So this will be 1 over 2e to the 2t minus 3, which if we simplify it, the 4 will cancel, so we get 2 on the top over te to the 2t minus 3. Okay, so now we have dy by dx equals to 2 over te times 2 to the power of 2e minus 2t minus 3. Now it says that when t is equal to a, the gradient of the curve is 2. So therefore we can say when t is equal to a, this thing equals to 2. So we can say that 2 over a e to the 2a minus 3, I've just subbed in a equal to t, equals 2. Right, so the gradient, all I'm saying is when t equals a, this equals 2. That's all that is. Okay, so now we just rearrange this. So the 2's will cancel, so that becomes 1, So we get 1 equals to a e to the 2a of minus 3. And it's always good to keep looking back. Okay, what are we trying to get here? Okay, so let's take the log of both sides. 1 equals to ln of a e to the 2a minus 3. And that, from our log rules, is the same as adding. Timesing these is the same as adding. And ln of 1 is 0. I don't even need to put that in my calculator. That's, if you understand what a log is, it will make sense that that's 0. So you get 0. I'm going to take this over on the side. So we got ln of a e to the 2a minus 3 equals to 0. And this can be written like this. We can split this up. Of e to a minus 3 equals 0. Well, this thing becomes ln of a plus, we can take that down, times ln of e equals 0. And ln of e is log to the base e of e, which is just 1. Again, don't need to put that in my calculator. And now I can see, okay, we're getting pretty close here. So now let's rearrange this. We get, so I get 2a equals to 3 minus ln of a. And so therefore, we get our final answer of a half of 3 minus ln of a, which is what they wanted. And that's what we gave them. You know what else is going to be an A? The final grade on your paper. Boom! Okay. Sweet, so we did that. Now it says verify by calculation that this equation has a root between 1 and 2. Okay, so we have a equals to a half, and this is numerical solutions. 3 minus ln of a. Okay, so what we want to do here is we want to take all this stuff over, and I'll show you why. 3 minus ln of a equals 0. So if we want to verify a root or a solution here to this is between 1 and 2, well, if we plug in 1, so let's say this is equation 1, I don't know, here, well, if we plug in a equals 1, then therefore our equation 1 becomes, or equals to, if we plug in a equals 1 here into your calculator, 1 minus a half of 3 minus ln of 1. So I got minus a half, so minus a half, minus 0.5, so this is negative. And when we plug in a equals 2, therefore our equation 1 becomes, now this should be positive, because if it's positive that means there's a root here or a solution, because this thing is meant to be equal to 0. So if it's going from just below 0, so negative, just negative, to just positive, then clearly there's a solution between 1 and 2. So then we plug in 2 minus a half of 3 minus ln of 2. Cool, and this is positive 0.84. So this is positive. So you can say as equation 1 changes from negative to positive for values a equals 1 and a equals 2, thus is a root or solution between them. So because it changes, right, so there is an a value here for which this equals to 0, and if when I plug in 1 it's negative, so it's just below 0, and when I plug in 2 it's just above 0, that means that just between those two there should be a solution for where it equals 0. Okay, use the iterative formula to calculate a to do 2 decimal places, showing the result of each iteration to 4 decimal places. Well, this is quite simple. So all we have to do here, so let's just write out that thing, 3 minus ln of a n. Okay, and so what we do here is we use one of these starting values, because how it works is when we iterate through it, it gets closer and closer to the solution. So we start with, let's say, the value a equals 1. So for a, so we can say for a1 equals 1, so for our n is 0. And therefore, so if a1 equals 1, well, a2, what is that going to equal? Well, we just plug this into here. So you plug it in, so a half of 3 minus ln of 1. Okay, and you get 1.5. And then you plug 1.5 into here, and you just iterate through, and you keep going. So you're A3, and it said it wants to keep this, so then you can just put it in answer, like just put the answer from here into here, and just keep going through. Okay, so the next one is 1.2973. That's 40p. A4, go answer again, 1.3699, A5, and you just continue through until you get to a sort of stable point where it's just fluctuating a little bit. 1.3464, A6. So I'm just keeping, maybe it's not necessary for me to write these all out, but whatever, we got time, we just chilling. A7. Okay, so I can see it's kind of fluctuating here. A90, A8. Yep, so it is fluctuating. 3503. So it's kind of fluctuating above and below 1.35 to 2 decimal places. So we can say that A equals to 1.35 to 2 dp. And if you want to be super, stringent about it, you could check that, okay, so A equal to 1.355, so just half above. This should be, so if you plug that into this thing again, and a little bit below, so would that be 1.345, a little bit below, well, one should be positive and one should be negative if you plug that in. I'm not going to do it, but you could plug it in to this formula here, equation 1, and so let's say that was positive and that's negative. Well, if there's one is positive and one's negative, well, again, that means it's switching just there in that tiny little interval between these two values. So it's just reassuring that this is the solution. So A is 1.35. Okay, and that's that one. Should we check that? Let's check it. What was it? Question 4? Question 4. $1.35. Oh yeah, and look, it even does say that as well. So show that there's a sign change in the interval. So that's exactly what I was describing before. So just checking that there's a sign change, meaning, so just checking that that is actually a solution. But I did that. I did both. Okay, cool beans. Okay, so we already did that in the last video. Okay, complex numbers. Did a great set of videos on Patreon for this one. We really pulled this one apart. This one's actually pretty predictable. They ask pretty similar stuff every year. Anywho, let's continue. Everyone good? Everyone beautiful? Everyone stressed out for their exams? I'm just chilling. I'm here. Yeah, I'm just here doing math. Definitely not sick of it. Because I've done a hell of a lot of maths this year. I look back on it and it's insane. But I guess I'm not sick of helping people, so that's good. Righto. Okay, so the complex numbers are u and v, so let's write out what they give us. 1 plus 3i. And v is 4 plus 2i. Find u divided by v in the form of x plus. They ask this shit all the time. So u divided by v, what is that? Let's just write that out. So 1 plus 3i divided by 4 plus 2i. And what we do here is we times the top and bottom by the complex conjugate of the denominator. So we times this by 4 minus 2i. And we do this because it gets us a constant on the bottom. Over 4 minus 2i, which is equivalent to doing nothing, right? Because we're timesing the same thing over the same thing, which is just 1. So And this will give us 1, 4 is 4. 1 minus, so minus 2i. 3 times 4 is plus 12i. And 3i times minus 2i is minus 6i squared. Divided by this times this is 16. Those two will cancel, and then so we'll just get a minus 4i squared. Okay, and remember I squared equals -1. So therefore we can say that u over v equals to, we get 4 plus 10i, and then minus 6 times minus 1 is plus 6, all over 16 plus 4, because I squared is -1, so that's 20. So that's equal to what? 10 plus 10i over 20, or simplify that, 1 plus I over 2. So in that form of this, we can say therefore that u over v equals to 1/2 plus 1/2 I. Tick. State the argument of u over v. Well, for these I just sketched them. So let's do a quick sketch over here. So what does this look like? Remember, this is our imaginary axis, and this is our real axis. So uv is at 1/2 on the real and 1/2 on the imaginary, and the argument is here. So what is that? Well, that's just going to be tan theta equals to 1/2 over 1/2. So the argument, so I just sketched it. This is, this is the u, whoa. This is our u over v. So just a quick sketch is equal to, well, this is going to be what? So tan theta at 1/2 of the 1/2, so therefore tan theta equals 1. So theta equals inverse of tan of 1. So this equals to the inverse of tan of 1, which equals to, which that's 45. Let's get it into degrees. So put your calculator in degrees, shift tan of 1, it's 45. I don't know if it's like cool or sad that I know that. Probably sad. Okay, so the argument of u over v is 45 degrees. Or you could write it as divide by 180 divided by answer. So you could also write it as pi over 4 if you wanted in radians. But we'll keep it in degrees. Okay. In our Gantt diagram, which is just the complex plane with the origin O, A, B, and C representing complex numbers U, V, and U minus V, state the geometric relationship between OC and BA. Okay, so we have what? U, so just rewrite it. U equals to 1 plus 3i. 1 plus 3i, which is our point A. V equals to 4 plus 2i. 4 plus 2i, which is our point B. And U minus V, well, that's just this minus this, will be 1 minus 4, which is minus 3. And 3i minus 2, which is 1. So just 1. So, and this is our point C. So let's sketch this to get an idea. And you should kind of keep it to scale because this is geometric relationship, so we want to see kind of what's going on here. So so point A is at 1. Remember, this is the real, this is the imaginary. So A is at 1, so let's call this 1 and 3. So let's say 1, 2, 3, 3i. So that's A. U, that's our U. V is at what? 4. So 1, 2, 4. This might be a little off, but whatever. You should draw it more to scale. Okay, so this is at 4 and 2i. So that's 2i and 4. So it's like here. So it's our B. So, this is our BA here. And then C is at minus 3. So that's 1, 2, 3. So minus 3 and 1. So I, which is there. So I'm just doing a rough sketch. And then origin is obviously in the middle. Okay, so I can see from the diagram that they are 1, they're parallel. And 2, they're the same length. We're going down 1 across 3, down 1 across 3. So equal length, or magnitude, I guess you could say. Okay, and it's 2 marks, so 2. I can't see any other geometric properties between the two things. Okay, and it says here, now show the angle AOB is pi over 4 radians. So AOB is this, AOB. So you know, if we have, I'm just going to redraw this, A, which remember is our U, that's our U complex number, and B, which is our V complex number. Well, the angle, and this is actually, even though it's a small mark, is small amount of marks, it taps into some pretty good understanding of complex numbers and arguments and stuff like that. Well, so first of all, our angle that we want is this one, so we can call it theta. So this is theta AOB. Right, that's that angle there. Yeah. And this is actually equal to the argument of A, which is that angle, minus the argument of B. So if you just look at this on the diagram, the argument of A is, you know, the angle between the complex number U and this positive real axis, and the argument of B is, you know, this part here, and the argument of A is this whole thing. So you can say that theta AOB is equal to the argument of U minus the argument of V, and you can just see that from the diagram. And now you could just work out these things individually and then minus them from each other, but this also comes down to your understanding, and this actually equals to the argument of U divided by V, and that comes from the properties of arguments, which I have gone through in detail in my video on complex numbers and stuff like that. But yeah, it just comes down to a property. You know, the argument of the complex number of U divided by V is the same as the argument of the complex number of U minus the argument of the complex number V. That's just, it is, and I have proofs for that and stuff. But okay, so that makes it a lot easier because we know what this is. This is this. We already found it. So therefore, the theta AOB equals to 45 degrees, or pi over 4 radians. Boom, baby. Should we check those? Okay. Half, which is what we got for the first one. 45, we got that. Equal in length, parallel, we got that. And look, that's exactly what they said, and that's exactly what, so the argument of U minus the argument of V is equal to the argument of U over V, therefore the answer is 45 degrees. Cool. So all of those are correct. Let's keep going, let's keep running. And we've got this one, and how many more? And that one, and we've already done that last one. So we've got 2 more. Got a vector one, and then looks like an integration one. Okay. So we've got some weird geometric object which you'll probably never see in your life. I don't know, maybe you could see that. What does it look like? Maybe some weird door stopper? Fuck, I don't know. Anyway, you probably never see this thing. So what's going on here? So it's important that we read this stuff. Okay, so AO is 2 units. So I always like to write vectors in vector form. So that's just me. So, you know, OA here, this is 2I. So that's going to be 2, 0, 0. OB, so I'm just writing out what they're giving me. OB is 4 units, but in the J direction. So that means it's going to be 0, 4, 0. And OC is 2 units in the K direction. I'm just looking from the diagram. It's a 0, 0, 2. Okay. The edge of OC, blah, 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 blah. So IJK. The midpoints of AB and BC are M and N. So these are the midpoints of BC and AB. Express the vectors ON and CM in terms of IJ and K. In terms of IJ and K, okay. Well, I'll do it in vectors and then I'll rewrite it in IJK form. Okay, so ON. So you need to write this as a construction of two vectors. So ON, let's have a look on the diagram. So ON is ON. So that is, you could say OB minus BN. Okay? Just from the diagram. So that's OB minus BN. Now OB is already, we already have that. It's just for J. But BN, so this is going to be OB minus, now what is BN? BN is half of BC, right? Because N is the midpoint of BC. So this is half of BC. The vector BC. And what is the vector BC in terms of, remember we need it in terms of these OA, OC, and OB because that's IJK. Okay, so BC is just minus OB plus OC, or OC minus OB. So therefore we can rewrite this as OB minus a half of OC minus OB. OC minus OB. Okay, so we've got 1 OB minus half OC and then minus a half OB, so that's what? Plus OB. So this is equal to what? 3 over 2? 3 over 2 OB. Well, I feel like what am I doing? OB minus, so ON is OB minus BN. No, not minus BN. Plus BN. See, that was where I made my mistake. OB plus BN. I'm getting confused here. OB plus BN, okay, and then this is equal to OB plus a half, so the same as what I was saying before, a half of BC. And what is BC? BC is equal to, what I had before, is equal to a half of OC minus OB. OC minus OB. Which equals to, we have OB plus a half of OC minus a half of OB. This equals to a half of OB plus a half of OC. Right, and so therefore ON equals to, well, a half of OB is 0.42, is a half of OB, which is 0.20, plus half of OC, which would be half of this, which would be 0.01 instead of 0.02, so 0.01. So this equals to 0.21. Okay. Sorry, I just tripped up a little bit. 0.21. Okay, and then we need CM. So let's do the similar thing. CM equals to, so in IJK form, that would be what? ON equals to 2J plus K. So that would be in IJK form. CM equals to, CM, so where's C? So CM will equal to, how do we want to do this? C to M. I'm going to go CO, or minus OC, you could think about it. So I'm going to go CO plus OA CO plus OA plus AM. Plus AM. So this is equal to, well, this is just minus OC, right? So it's minus OC or CO, but we want it in the with OC, plus OA, and then plus AM. AM is half of AB. Half of AB. And what is AB? Let's do a little jot here again. Well, AB is just minus OA plus OB. So minus OA plus OB, which equals to OB minus OA. Okay? So therefore we get CM equals to, we've got OA here minus OC plus half of AB, and AB is OB minus OA. OB minus OA. Okay, so this equals to, well, we've got OA minus a half of OA, so that's just a half of OA. And then we've got plus a half of OB, and then minus OC. And what is that? Well, therefore we have CM equals to a half of OA is a half of this, which is 100, 100, plus a half of OB is 020, 020, minus OC, which is 002, 002. So this is going to equal to what? 1, 2, and minus 2. So therefore CM equals to 1, 2, and minus 2. And look, I'm just doing it by just looking at the diagram. So that's your answer. And in IJK form, that would be what? So I plus 2J plus, minus 2K. So let's check that quickly before we go on to the other ones, because I was a bit shaky there. Here we go. 2J plus K, 2J plus K, and then I2J minus K. Excuse me. I2, yep, okay, so we got that right. Calculate the angle between ON and CM. Okay, so we have this thing, so we have ON, so let's just do a little sketch. So ON, and what? CM, so let's say this is M and C. So we're going to get this angle if we just plug it into that thing. So remember that cos theta equals to, if we want the angle between these two vectors, well, we just plug it into this formula. It's a pretty easy one. Okay, so let's work out all these things individually. So remember that ON equals 2, so just quickly jot down these things again, 0 to 1, and CM is equal to 1 to minus 2. Okay, so the dot product of these two, so ON dotted with, man, my writing's getting crazy bad. ON dotted with CM is equal to 0 to 1 dotted with 1 to minus 2. This equals to 0, and then we get 4 minus 2, which is 2. And then the magnitude of ON, well, what is this? This is going to be the square root of 0 squared plus 2 squared plus 1 squared, which is what? The square root of 5. And CM, the magnitude of this, so the length of this is going to be what? 1 squared, 2 squared, so it's going to be 1 plus 4 squared, just squaring all those things. This equals to what? The square root of 9, which equals to 3. Okay, so therefore the cos theta is equal to 2 over 3 square root 5. Just plugging all these things into this formula. And so therefore theta equals to 2 divided by answer. 72.65 degrees. Okay, let's see if that's right. Okay, 72.7, so they rounded it. So I rounded it up. Okay, so we got that right. Cool beans. Okay, and now this one. Show that the length of the perpendicular from M, and they actually ask this kind of thing all the time, but this one's actually quite difficult. It's not crazy difficult, but it is difficult. So show the length of the perpendicular from M to ON is this. Okay, so we've got this line, ON, right? And then we have the point M, and which is here, and it wants the length of, let's say there's this point P on this line ON. It wants the length of this. So let's say it wants the length of MP. It wants to know what this is when this is perpendicular. Some P is some arbitrary point. That's where it's perpendicular. So first of all, to do this, we're going to need the line, the vector equation of the line ON. So I'm going to call ON, so the line ON, I'm going to call this L1. So L1 is R1, the vector which defines this line ON, and that equals to a point on the line, which will be the origin, plus the directional vector of this line, which is just the directional vector of ON, which is 0, 2, 1. So this equals to lambda of 0, 2, 1. So we have the vector equation of the line ON. And why do we do that? Well, we did that because, and also we need M, so OM. Do we have OM? No, we need OM as well. So OM, so let's just draw this. OM, maybe we'll just figure it out there. So OM is just equal to, so OM, because we need the positional vector of this point. So OM is equal to OA plus AM, which equals to OA plus half of AB. And we already figured that out. Half of AB, which was a half. Oh, fuck it. A half, this is OA plus a half of OB minus OA. So I'm just trying to work out OM here for the question. So this is equal to, so this is going to be a half of OA plus a half of OB. Right? Yep. So this is going to be a half of this will be 1, 2. So this is going to be 1, 2, 0. Oh, a bit too far. So OM, we just calculated above, is 1, 2, 0. Okay, so we need, so we have OM. So we need PM. So what is PM? Well, R defines this line OM. So PM is equal to, this is our R1, or MP, I call it MP. MP is equal to minus OM plus R, which is, and the reason I'm not explaining this in detail is because I've gone through it before. This is really just like, I'm just showing you how done, because R defines this line. So R minus OM, this defines PM, the length PM. And R is this, so therefore MP equals to this lambda of 0, 2, 1 minus OM. OM was 1, 2, 0. So this equals to, well, this equals to 1, and then we have 2 lambda minus 2. Oh, this will equal to minus 1, my bad. And this will equal to what? 2 lambda minus 2 and then lambda on the bottom. Okay, so therefore MP is equal to -1, 2 lambda minus 2 lambda. Okay? But we need lambda. We need to find the specific lambda which gives this P, where P is perpendicular to M. Well, the specific lambda, we can find that because it occurs when they're perpendicular to each other. So that means that it occurs when MP dotted with the directional vector of this line ON, which is what, 0 to 1, when this equals 0, because that's when they're perpendicular to each other. That's from that cosine rule for the theta. When the theta is at 90 degrees, cosine of 90 is 0. Okay, so this occurs when, so therefore, we get the dot product of -1, 2 lambda minus 2 lambda, dotted with 0 to 1, and I'm running out of space. Awesome! So this is going to equal to 0 plus 4 lambda minus 4, and then plus lambda equals 0. So we get what? 5 lambda equals 4. Just rearrange this so lambda equals 4 over 5. Okay, so we plug that back in, so therefore we get MP equals 2. If we plug this back in, we get -1, and then 2 times 4 over 5 minus 2, and then 4 over 5, which equals 2. 2 times 4 divided by 5 minus 2, so that middle one is -2 over 5. So this is -1, so -2 over 5, 4 over 5. So now we found MP. So that was MP. That whole thing was to find MP. And now we can find the length of MP. So therefore, the length of MP, because MP is our perpendicular length from N to the line ON, right? P was the point that I decided, is equal to the square root of, and remember we want to show that this is this, of -1 squared plus -2 over 5 squared plus 4 over 5 squared. And hopefully, if I did all this right, we should be getting in the vicinity of that. 2 over 5 squared plus 4 over 5 squared. I'd be pretty fucked off if I went through all this and just, got it wrong. So that, which is equal to what? The square root of, this is equal to 3 over the square root of 5. What do they want? 3 over 5 square root of 3. Okay, so we got MP equals to 3 over square root of 5. I can times this by square root of 5 over square root of 5 to get what they wanted. So this will equal 3 square root of 5. Square root of 5 times square root of 5 is 5. So therefore, we've shown that MP is equal to 3/5 square root of 5. Right? Which is what they had. Boom! Let's go! Okay. I hope this video is not going too long. And I hope it's useful. Okay, so we did that. And now we want to move on to this last one. And then we're finished. Okay. And then I'm going to take a fat nap. This is getting pretty late. Okay. Right. The diagram shows the curve of this for... Okay, so we have a curve which looks something like this. Cosine x. And it's between these limits. You know what has no limit? The universe. Food for thought. But math does have limit. Actually, it might not. We might be able to infinitely construct math. Just forever. Just keep making up more and more stuff. Or discovering. Depends how you want to look at it. So the maximum point M is a maximum. So find the x-coordinate of M. Okay, well this is just... So M occurs when dy by dx equals 0, because it's a maximum. So we find dy by dx. So dy by dx is equal to d by dx of this. And because we have two separate functions multiplied together, we have to use the product rule, which is on your formula sheet. It's here. So uv goes to v du u dv. So we're going to get, so we can say this is our u and this is our v. So v du, so we get cos of x times d by dx of sine squared of 2x plus, take it down, plus, and then v du, u dv, so we get sine. And I'm just plugging this into that formula. If you need to take a bunch of steps, then take a bunch of steps, but I've seen it so many times, so I don't need to. Times this. Okay, so therefore we get dy by dx equals to, well, this differentiated, if you just want to do this up here or something, well, this differentiated will go to 2 sine of 2x times, so I'm differentiating this. So this differentiated, so I take it out, so then I can use the chain rule. So this differentiated will go to 2 sine of 2x multiplied by this inner part differentiated. Sine goes to cos, so this would be times 2 cos of 2x. So this goes to 4 of this. So this is going to be 4 of sine of 2x times, okay, this is 6 marks, times cos of 2x. So that's that differentiated times cos of x plus sine squared of 2x times this differentiated goes to minus sine of x, so this goes to minus. Okay, and that when that equals 0, so now we need to solve this. Okay, immediately we can cancel a sine of 2x here, so we can cancel a sine of 2x, so we get 4 cos of 2x cos of x minus sine of 2x sine of x equals 0. I'll take a sine, take the sines over, so we get sine of 2x sine of x. So now I just need to solve for x, meaning I'm going to need to all get it in terms of one thing, one trig function. Okay, so I'm taking that sine over and I'm getting here, so this is 4 cos of 2x. So I'm thinking tan immediately here. So I'm going to divide through by that, so that will go here. So we get cos of 2x sine, cos of x, which is the same as saying sine of 2x over cos of 2x times sine of x over cos of x equals 4. This is tan of 2x, and this is tan of x. So we're getting somewhere. And tan of 2x, well, if you go on your formula sheet, is what? It should be here. Tan of 2x is 2 tan x over 1 minus tan squared x. So this is the same as saying 2 tan x over 1 minus tan squared x times tan x equals 4. Okay, let's do some more rearranging. And again, I'm running out of space because they don't give us enough space, man. It's bull. 2 tan squared of x equals 2. I times through by that, I get 4 minus 4. And if I'm going too fast, you take more steps. But time is of the essence. Okay, and so then I take what? This over here, we get 6 tan squared x. Plus I don't have enough space, hence why I'm not taking as many steps. So I get tan squared of x equals 2. 4 divided by 6, which is the same as 2 over 3. Then I square both sides, so therefore I get x equals to the inverse tan of this. So square root of 2, 2 divided by 3, square root of that, and then shift tan of that. is, I got 39.2 degrees. Should we check that? It was a big question, you know. Oh, it wants it in radians. Okay, you got to put the answer in radians because they give you the limits in radians, and also, you know, everything else is in radians. Okay, so I'll just change my thing to radians. So 2 divided by 3 square root answer shift 10 0 point. So in radians it's 0.685 radians. Which I think, yep, that's exactly what they got. Awesome. Okay, we got that right. Okay, last one. Let's go. Okay, last one. Using the substitution u equals sine of x. So this is the integration question where we're using substitution. Find the area of the shaded region. Okay, so the area of the shaded region, the area of the shaded region is equal to between pi over 2 and 0 of sine squared 2x, sine squared 2x cos of x dx. So that's what we need. We need to figure that out by substituting in u equals this. So if u equals sine of x, and I already know I'm not going to have enough space, if u equals this, then du by dx, so this is just something I'd start doing, is equal to cos of x. So therefore dx equals, du, sorry, du equals to cos of x dx. Okay, and we can already see we have that. So what I'll do is I'll take away the limits and stuff like that, and I just want to figure out what is this? What is this integral? Well, we can't solve this. How the hell do we solve that? If you go on your formula sheet, you've got nothing, no tools in your toolbox to solve this. But if we make the substitution according to them, it's going to get a lot simpler and we're going to be able to solve it. So immediately I'm going to say, okay, well, I can plug du in. So this is the same as saying sine squared of 2x equals to du. Times du, because this is just du, right? Okay, so now let's see if we can do something with this. The sine squared of 2x. Well, what is sine squared of 2x? Well, this is equal to sine of 2x squared. And what is sine of 2x? Because we need to get it in terms of sine, because we're making a substitution for sine. Can't have sine 2x. Can't be getting crazy over here, you know? Sine of 2a is 2 sine a cos a. So this is equal to 2 sine of x cos of x from that formula squared, right? And that equals to 2 sine squared x cos squared x. Oh no, 4. Almost made a mistake. Squaring it. Okay, and cos squared x is equal to 4 sine. So I'm just changing everything into sines of 1 minus sine squared x, which equals to 4 sine squared x minus 4 sine 4x. Okay, and if I want to now put this into u's, well, this is equal to, okay, well, therefore, we can say, therefore, that this thing now becomes 4 sine squared x minus 4 sine 4x du. So now we have it in terms of all of sine of x. That means that we first of all we could take out a 4, and this becomes u squared, because u is sine x, minus u4 du. And this is definitely something I can solve. So this thing is the same as this thing. I've just means that u is sine of x, and this is something we can solve. This will equal to what? 4 times u3 got up by the power, divide by power, minus u5 over 5. Okay? And now we can plug back in what u was and put it between those limits. So if we actually want the area, this is going to equal to 4 times, well, this is sine of cubed x over 3 minus sine to the 5x over 5 between the limits of x equals pi over 2 and x equals 0. You could have kept it like this and done it between the limits of what u would be, but then you'd have to sub it in and see what u would be. But I just changed it back, so this is the one way to do it. Okay, so now you can figure it out. So therefore, the area is equal to 4 times what am I doing? 4 times this, well, sine of pi over 2. Sine of pi over 2 is 1. So this is 1 cubed over 3 minus, so I'm just substituting in the points, minus 1 to the 5 over 5 minus, when x is 0, well, sine of 0 is 0, so this is going to be 0 minus 0. Okay, so therefore the area under that graph is just this. So we get 1 over 3 minus 1 over 5 times 4. So this is 8 over 15. That's the area, hopefully. Let's look. Yep, 8 over 15 right there. Sweet! Perfect. Okay, so I finished that paper. And like I said, that will be the last P3 I'm doing on YouTube. Everything else will be on Patreon. Any extra stuff I want to do, obviously I've already done all the exam hack series on Patreon, so go grab that. Hopefully that was useful. Like, subscribe, and I will see you in the next video. Bye-bye.